Hey.
Well, first, I want to wish you a great trip. Lucky you if you're getting away here in the middle of January. If you're going to Playa del Carmen, it's about 20 degrees, partly cloudy. Puerto Vallarta, 31, lots of sunshine there. In Cancun, same deal. Los Cabos, Punta Cana, lots of sunshine to enjoy. Pack the sunscreen. If you're going to Montego Bay, Jamaica, we're looking at 28 degrees, even warmer for Puerto Plata, Dominican Republic, and then Nassau, Bahamas, 26, partly cloudy. So enjoy your trip and make sure you pack your bathing suit. Today's Science Behind the Weather, we talk about an event that happened in the last week of December 2013 for downtown Toronto and much of Ontario when they saw the biggest ice storm they've experienced in years. And we had scenes like this with major ice accretion on the trees, down powered lines. But what was interesting is what happened after the storm. Temperatures plummeted. And then we heard reports of people hearing loud noises, loud bangs in downtown Toronto. It sounded like an earthquake. So was it an earthquake or was it a frostquake? Well, you guessed it. It's the second one, frostquake, also called a cryoseism. That is interesting because it's not actually tectonically active. So it's not Earth's tectonic plates moving, shifting apart or together. It has everything to do with water expanding or contracting. So water seeps through the rocks in the surface, say in downtown Toronto, and then that expands when we have frigid temperatures. And boom, you get the noise of that expansion. And that can travel for hundreds of kilometers. Today's Science Behind the Weather, we're going to talk a little bit about circulation pattern on a tilt of about 23.5 degrees. And whether it's tilted toward the sun or away from the sun will determine length of day, the season, and how much solar radiation the Earth gets at any given time, how much heat, those sorts of things. Have you ever thought about circulation patterns? In other words, low pressure and high pressure. How do they work? How do their winds work in both hemispheres? Well, an area of low pressure has winds that spin cyclonically around an area of low pressure, spinning into the center. And then we have a high pressure area that has the opposite, spinning anticyclonic. If we go to the southern hemisphere, it's the opposite again. So an area of low pressure actually has anticyclonic winds, and it goes the other way around an area of high pressure. But the toilets still flush the same way in both hemispheres. Thanks for joining us. I'm Jaclyn Whittal. We'll have coast-to-coast coverage with all of our correspondents right across the nation in just a second, but we'll start you off with a story in the east where we're seeing rain showers in the middle of January. Very mild temperatures, one low after another moves on shore. This next one should just clip the southern shores of Nova Scotia, and then into Thursday night, that's tonight, into tomorrow morning, we have this mixing line in northwest Newfoundland and right through PEI as well. So could be a little bit slippery through there. But yes, spring-like. Let's go to Nathan Coleman now, who's wearing his sunglasses. Nathan, we'll take it. Hey, you know what? If you're asking me, Deb, you deserve it because you've had a very cold month of December. And let's go to the story into the prairies. We're dealing with these winds, as the girls both just mentioned. It's the big story in Alberta plus Saskatchewan and now pushing in through Manitoba next. We have heavy snowfall associated to that warm front. Once it moves through northwestern Ontario, could see 5 to 10 centimeters of snow. Stay with us. Your long range is ahead.
Go to theweathernetwork.com.
Fog is basically a cloud down on the ground. But how do we get a cloud to form at the surface? Well, let me see if I can help you understand. Basically, you need a few key ingredients, and it has to do with what our weather has been doing during the nighttime. We need clear conditions and calm winds. And all of that daytime heating that we've had throughout the day can escape from the surface or radiate from the ground. And that's why we call it radiation fog. And it can cool the air right down to the ground. In fact, it cools it right to what is called its dew point. Basically, when we have a water vapor or gaseous water stage turn into liquid form, and then it condenses out into a cloud. And just like when you're flying in an airplane through the clouds and it's tough to see out your window, so could be the same state when you're out on the roads driving through fog. So stay safe out there and keep it here at the Weather Network.